All right, folks, I have configured or I have created a very simple topology. You have router 1 connected on S000 to router 2 S000. The IP addresses on these interfaces are, if I say do show IP interface brief, router 1 has an IP address of 200.111, and router 2 has an IP address of, unfortunately, I've named this router 1 also. Let's change the name to R2. So router 2 has an IP address of 200.112. If you look at the interface itself under my running config, you see that I've assigned a mask of 252, 255, 255, 255, 252, or /30, which is supposed to be used on point-to-point links. If I look at my interfaces, show int S000, first thing you will see that serial 000 is up and line protocol is up and it's connected. And you also see that the default encapsulation type on my serial interface is High Level Data Link Layer Control, or HDLC. Let's try and ping across from router 1 to router 2 and make sure, absolutely sure, that we can connect, we can ping. So I'm sitting on router 1. I'm going to ping 200.112, and we are pinging. Now, let's go ahead and see what happens when I change the encapsulation type to PPP. Now, before I do that, let me show you the routing table of router 1. Show IP route. Do show IP route. Now you see the only connection or the only route showing up on router 1 is my 200.110 network, which is directly connected to serial 0. And router 2 would show the same. Now let's go ahead and change the encapsulation type to PPP with the command encapsulation. If we do a question mark, there are three options. We have seen HDLC. We're going to try and attempt to change to PPP. And then later on, we'll discover and explore frame relay. So encapsulation PPP, enter. And I got a message saying that line protocol on interface serial 000 has changed to down. If we look at our interface brief, you see that the line protocol says down. Status says up. So layer 1 says up, but layer 2 says down. The reason being that at the other end of the link, on router 2, we still have not changed our encapsulation to PPP. So router 2 being HDLC on serial 000 and router 1 being PPP on serial 000 creates a mismatched encapsulation type on the two ends, which takes the link to up-down. If we go ahead and go into serial 000 on router 2 and change the encapsulation to PPP, you immediately see that the line protocol on interface 000 has gone to up. If I look at my interface brief, do show IP int brief, and you see that we are up now. If I ping to the other side, 200.111, me right now being on router 2, so I'm going to ping router 1, and it works. Now let's go take a second look at our IP routing table on router 1. So if I execute the command do show IP route, we see a secondary route that has been installed in our routing table. Now, PPP automatically installs a host route. And if you remember, a host route is a route with a /32 mask to the opposite end of the link. This is called a peer neighbor route, and this is a function of PPP. This got automatically installed in our routing table once we changed the encapsulation to PPP. This is default PPP behavior. So I have a direct route to the 200.112 address on router 1. And if I check on router 2, you will see a direct route to the 200.111 address on router 2 with a /32 mask. And here it is. Once again, this is called a peer neighbor route, and this is default PPP behavior. Next, remember I said that PPP can perform authentication between two devices so that each device can authenticate the other and make sure that the device talking to us is who they say they are? Well, there are two protocols that PPP uses for authentication. First one we're going to cover is password authentication protocol. So if I execute the command PPP authentication and execute the help feature, you see that there are two protocols that control authentication over PPP links or point-to-point protocol links. The first one we're going to cover is PAP. PAP sends the password over the link in clear text, which is not good. However, it is part of our CCNA, so we're going to cover it anyways. Now, what is going to happen is one side of the link, router 1, is going to be the authenticator. And the other side, router 2, is going to be the authenticatee. So if router 1 is going to be the authenticator, first we need to have a database against which router 1 can authenticate router 2. We create this database locally by executing the command username and then the host name of R2, router 2, which is lowercase r2. So I simply type in R2, and then with a question mark command, I see this option password. So I'm going to create a password that router 2 must match with router 1 to authenticate itself. Password, and we're going to leave the password as, or create a password saying Cisco. So the password being Cisco. Next, I'm going to log into the interface or go into interface serial 000 of router 1 and tell router 1 that it is going to be the authenticator by executing the PPP authenticate, and then since we are doing PAP or password authentication protocol, remember password authentication protocol sends the password over the link in clear text. Now router 1 is trying to authenticate router 2. At this point, if I look at my link with the show IP interface brief command, you will see that the link has gone up down. If I debug PPP authentication and debug PPP negotiation and debug PPP packet, you will see that PPP is sending packets back and forth, or trying to at least authenticate router 1. But at this point, PPP is unable to authenticate, router 1 is unable to authenticate router 2, so the link has not gone up yet. As you see, the link control protocol state is open, but the link is still down. If we go on router 2, the authenticatee and go into interface 000, which is connected to router 1, and say PPP authentication, or PPP PAP, since we're using PAP, or password authentication protocol, then send username, and the username we are sending is our host name, R2, and then the password. The password that we send here and the username that we send here must match the database that we created on router 1. Namely, if we go to router 1, and I look at my running config, you look, I created a username for our router 2 as R2 and the password Cisco. When router 2 tries to authenticate itself with router 1, this host name and this password must match to what router 1 has in its database. The database for us is just one line. This could be many more lines if there were other routers. So we go back into router 2. Well, let me go ahead and turn authentication debugging on router 1 so we see something. Debug PPP authentication and debug PPP events. PPP negotiation. Go to router 2 and we say PPP pap send username R2 password Cisco. At this point, the link you see came up, and on router 1, you see that router 1 finally got the username R2 and password Cisco from router 2, and it authenticated router 2, and you established your connection. You finished the LCP phase, and the connection is up, and the interface came up. If I look at my show IP interface brief command again, you will see that my interface is up and up, and I should be able to ping 200.112, that being router 2. Next, we are going to explore CHAP.